Welcome to Naresh Technologies. I am Bangaraju, and in this video we will understand about how exceptions occur in our program and how we can handle these exceptions in the code. It's a continuation video for our previous thing what we have learned in the previous session or a previous video, like what is an exception. So here I want to give a clear picture how to handle these particular exceptions when they occur in the code. First, let me explain you how these exceptions will occur, then we'll see how to handle the exceptions. Fine. As per our discussion in the previous video, I said you exception is a class, and the instance of this class comes into picture to perform or to cause abnormal termination whenever there is a runtime error in the program. So whenever runtime errors occurs in the program, these exception classes will come into picture for causing abnormal termination. And also said it's not one exception class, there are various exception classes available where each class is defined representing a different type of exception. Like if you try to divide a number by 0, we got an exception called as divide by 0 exception. If we try to perform an invalid type conversion like a string value to int which is not compatible, we'll get a format exception. If at all we're trying to give a bigger value than the capacity of a type, you'll automatically get a overflow exception. Like this, there are so many classes that are present for you under these exceptions. So I'll show you today how are we going to control these things. Means first let us understand how they will occur, and then we'll see how to control. I want to write a simple program here for dividing two numbers using system class exception demo static void main console.write enter first number int x is equals to int dot parse int z is equals to x by y. Now I'm trying to just take two numbers and divide the number, that's all. And here writing console dot write line. The result is plus z and console dot write line end of the program. It's a very simple code what I done. I'm just taking two numbers from the user, trying to divide them and print you the result. That's it. Let me save this. So exception demo.cs. I just saved it in a folder called C#. So now let us compile the code. CRC exception demo.cs. Let's execute this. Exception demo. Just a second. Just opening the program code, that's it. Compile it. CRC exception demo.cs and execute it. Exception demo. Asking for a first number 100, second number 5, and you can see it is printing the result, it is printing the end of the program. Everything is perfectly executing, so no mistake at all. But there are chances of getting some runtime errors in this code. What is that? Watch. I am re-executing my program, giving the first number as 100, second number as 0. Exception arises. Why? An error is going to occur in this program now. Why the error occurs? Because it's a universal rule. We can never divide a number by 0. It is going to be a universal rule. We can never divide a number by 0. So because you are trying to divide a number by 0 on this line, exception will arise. So exception is going to arise on this line. How the exception arises? Watch. all the .NET applications will be running for us under the monitoring of the CLR. So the CLR is going to monitor the applications, and the CLR is going to be the execution engine which is responsible for running the programs, and all the programs will run under the supervision of the CLR. Because the CLR is going to monitor your code, and when the execution is going on, CLR identifies a mistake on this line. When CLR identifies a mistake on this particular line, what it does is, first it will stop the program and check out what is the mistake. What is the mistake? User is trying to divide a number by 0. And this is completely against the rules. Why? Numbers cannot be divided by 0. So it's a universal rule. You can never divide a number by 0. So right now this operation should not be permitted. So because it should not be permitted, what the CLR is going to do now is, it will pick the class, that is associated with this error. Representing this error, there is one class now. What is the class? Divide by 0 exception. So CLR will pick that class now. And now CLR will create the instance of that class. Which class? Divide by 0 exception. And throws that object. And the object which is thrown by the CLR is coming now to perform an abnormal termination. The object will come into picture and will perform the abnormal termination now. And once abnormal termination is performed, automatically it is going to display you an error message about the error. But these 2 lines of code will not execute. Why? Whenever an exception occurs in the code, the program terminates abnormally on the same line without executing the next lines of code. You got an error on this line, so abnormal termination will occur on this line only. Watch. Unhandled exception, system.divide by 0 exception, attempted to divide by 0. It is displaying you an error message about the exception. So CLR is actually responsible for creating the instance of the exception class and throwing it. And the instance or the object thrown by the CLR will come into picture and destroy the program abnormally. See, is an abnormal termination here. What is the proof? These 2 lines of statements did not execute. These 2 lines of code did not execute for us. So because the 2 lines of code did not execute, we can understand. What is that? Termination happened on this line only. These 2 lines did not execute because the termination happened on this line. So that is what we call abnormal termination. Okay. Still, lot of different types of exceptions will occur. Watch. I'm giving 100 and I'm trying to give the second number as y. Exception occurs. Why? Y cannot be converted into integer. So on which line the error occurs? On this line. You're calling parse. Y cannot be converted into integer now. So because y cannot be converted into integer, exception will arise for you on that line now. What happens? Exactly same. CLR is monitoring. CLR checks out what is the problem. You're trying to perform an invalid type conversion. So what is the class associated with this error? Format exception. Will create the instance of that class and throws it. And the instance which is thrown by the CLR will immediately do its job. What is the job? Abnormal termination and displaying a error message. Again, abnormal termination occurred. But what is the exception now? Format exception. Earlier, divide by 0 exception. See, one more time I'm executing. I'm giving wrong value in the first number only. There only abnormal termination. It won't ask you the second number. Why? There is no point of asking the second number. When you have an error in the first line, it is not required to ask you the second value and do all these things. So that's why abnormal termination occurs for you on that line. Which line? Here only abnormal termination is occurring now. Why? Parse. It is trying to parse, cannot convert, and abnormal termination. So how this abnormal termination is occurring? CLR is creating an instance and throwing the instance, and the instance thrown by the CLR will now cause abnormal termination in the program. So that is what exactly happening for you whenever a runtime error is there inside a program. Simple. I have a glass window over there and my hand has a cricket ball. If at all I'm going to throw this cricket ball on the glass window, once it goes and hits the glass, automatically the glass breaks. So what are we doing? We are destructing. So we are destruction, that's what we are doing. Exactly. The object thrown by the CLR is also going to do the same thing only. What is it doing? Destruction. That abnormal termination comes into picture because of the object thrown by the CLR. So this is how the exceptions will occur in the program. So what happens? Whenever there is a runtime error, CLR will create an instance of a matching exception class and throws it, and the instance which is thrown by the CLR will immediately perform an abnormal termination. Okay, that is how the exceptions are going to occur for you in the code. Now, we cannot leave these exceptions like this. Why we cannot leave? Because if this type of abnormal termination are going to occur in the programs now, tomorrow when the end user is running or the client is running, always any problem like this, the application will shut down. So it has to be controlled. How to control? To control this, we have a mechanism called as exception handling. We have a mechanism called as exception handling. What is this exception handling? Exception handling is of stopping the abnormal termination of a program whenever a runtime error occurs inside the program. So just now we watched, whenever a runtime error is occurring, program is terminating abnormally. So exception handling is a process of stopping the abnormal termination of the program whenever a runtime error is occurring inside of the program. So whenever the runtime error is occurring, abnormal termination is coming for. Now to stop that, we use exception handling. So handling an exception has three advantages. One, abnormal termination stops, so that statements that are not related with the errors can be executed. Second, we can display user friendly error messages to the end users so that we can describe about the error. We can perform corrective actions to resolve the problems that may come into picture due to the error. So these are the three benefits what we have. Abnormal termination stops, so that statements that are not related with the error can be executed. If you understand the previous program, in the previous program, this statement is in no way related with the error. But whenever an exception is arising, the statement is not executing now. So that's what, when that is no way related with the error, it is not fair stopping the execution of that line. So now if you can handle the exception, automatically you can make the statement to execute. Okay, so this is what the first advantage. Second, we can display user friendly error messages to the end user so that we can describe about the error. What exactly I mean to tell is, every exception is associated with a predefined error message, but those predefined error messages are not end user friendly. Then these messages are programmer friendly. Programmers can understand, but not end users. So if you want to make the end user to understand about the error occurring, we can display some error messages which are understandable to end users. That's what we can display, user friendly error messages to end users. Third one, we can perform corrective actions to resolve the problem that may come into picture due to the error. Yeah, what is it? Sometimes some problems may occur because of the runtime error. Some problems may occur, and to resolve those particular problems, we can perform some corrective actions. Suppose we are trying to perform a funds transfer operation, transferring money from one account to another account. So there two update statements will execute. First update will deduct the money from the source account. Second update will add the money to the destination account. So now after executing the first statement, if at all you get an exception, second statement will not execute. So what is the problem now? First statement executed means money deducted now. Second statement did not execute means money is not added to the destination. So there is a problem. So to resolve these type of problems, you can perform a corrective action. What is the corrective action? The corrective action is roll backing the transaction. Once you roll back the transaction, the first operation also will fail. So after deducting the money, exception occurred and the second statement was not able to execute, means first statement also should be cancelled. For that, we require to perform a corrective action called as rollback. Like this, in different scenarios, we perform different corrective actions. So that is the third one what we can do. So these are the three advantages of handling an exception. Now, how to handle this exception? To handle an exception, we need to put our code. We need to put our code under two special blocks called as try-catch blocks. Try-catch blocks. By putting the code under these try-catch blocks, we can handle an exception. How to use them? Watch. Try with some statements, catch exception class name followed with a variable and some statements here. Some statements over there. So like this, we can put the code in the try catch block and handle the exception. But here we require a clarity. What clarity? You are asking to write some statements in the try, but what statement should I write in the try? What statement should I write in the catch? Let's understand. Statements which will cause runtime errors. You need to identify the statements which will cause runtime errors and you are required to put them in the try block. Second, statements which doesn't require execution, which doesn't require execution when the runtime error occurred, also should be inside the try block. So the statements which will cause runtime error and the statements which doesn't require execution when the runtime error got occurred also should be in the try block. Then what about catch block? Statements which should execute only when there is a runtime error. Whatever statements we want to execute only when there is an error should also be present in the catch block. So this is how you should arrange or organize the code. By putting the code like this, we can handle the exception. Let us practically see this now. Our previous program is causing some exceptions now. And we'll try to put this code in the try catch block and handle this. Let me write a new program. I called it as a try catch demo. Using the same code here. And already we just checked out. This is going to cause errors. So to control the error, I want to put this code in the try catch block. If you want to put the code in the try catch block, the first thing you require to do is identify what statements will cause runtime error. Come on. Will this cause any runtime error, miss? No. What about this? Yes. What about this? No. This one, answer is yes. Again here, yes. What about this? No. And what about this? No. So these three lines, int x is equals to, int y is equals to, int z is equals to, will cause runtime errors. So let's put that code in the try block now. I will start with try here. All the statements I am putting in the try block. All the statements I am putting in the try block. Next, what next? The statements which doesn't require execution when the runtime error got occurred also should be in the try block only. Whatever statements we don't want execution when the error got occurred also should be inside the try block. See, when the error occurred, I don't want this statement to execute. Why? When there is an error, there is no point of displaying the result now. So I am going to put this statement also inside try block. So this is also going to be present inside the try block now. So what did you put in the try block? The statements which are going to cause the error and the statements which doesn't require execution when the error got occurred. See, if you get an error on this line, no need of executing these 4 lines. If you get an error on this line, no need of executing these 2 lines. If you get an error on this line, no need of executing this line. So what you have in the try? Statements causing the error, statements which doesn't require execution when the error got occurred. Okay, fine. Next, catch. Catch what? Name of the exception class. I want to handle divide by 0 exception. Divide by 0 exception followed with a variable ex1. And now here what you write, any corrective actions if present or error message displaying should be done at this location. So for this I don't have any corrective action, but I want an error message to be displayed. See, when you're displaying an error message, you have 2 options. Option number 1, you can display the error message that is associated with the exception. Divide by 0 exception is associated with an error message. You can print it. How? ex1 dot message. What is that message? Message is a property. Message is a property under the class divide by 0 exception, and this is going to return you the error message associated with that class. That message will be displayed. No, I don't want predefined error message. Then write your own error message in that place. Any of the things you can do. So right now I am using predefined error message. Let us see. Compile the code. And now I am executing the code. 105. There is no error. So result is printed, end of the program is printed. Now I am giving 100 and 0. There is an error. What error? Divide by 0. So on this line there is an error. When there is an error, what CLR will do now? Create the instance of divide by 0 exception class and throws it. And the instance which is thrown by the CLR coming now to perform an abnormal termination. But what happened here is, before it is going to terminate abnormally, my catch block is going to catch that instance now. So once the instance is caught now, abnormal termination stops there. And that instance is stored under ex1. What is ex1? Variable of the class. Remember, the instance of a class can be assigned to the variable of a class. And once the assignment is done, ex1 is a reference to my class. Which class? Divide by 0 exception. The point to understand here is, I given you an example earlier. There is a glass window and I have a cricket ball, and I am going to throw this particular ball on the glass window. Once it hits the glass breaks. But before it hits the glass, if someone comes and catches it in the middle, so once someone is going to catch the ball in the middle, your glass will not break. Exactly the same thing is happening now also. What is it? CLR threw the object, but my catch block caught that object. Once catch block is catching the object, abnormal termination stops there. And now that object is stored under ex1. And after storing it in the ex1, it will enter inside and display the message to you. What's the output? Error message. Attempted to divide by 0. Next, end of the program. This is a proof to you to show you abnormal termination did not occur. Why? End of the program statement got printed. Means there is no abnormal termination. Okay, fine. Now I am trying to run the code one more time. But now the exception that arises is format exception. So because of the format exception now, exception will occur. Why exception occurs? Because the current catch block cannot catch format exception. What it can catch is only divide by 0. Then what about the second exception? If that is the case, you can add one more catch block here. Catch format exception ext. So we have a second catch block now. If the first fielder cannot catch the ball, the second fielder is trying to catch the ball. Exactly the same thing. The first catch block will try to catch it. If it cannot catch, then second catch block will catch it. So I'm again going to write the code inside. Console dot write line. We can display predefined error message, or I said you, second option is there, user defined error message. Here I want to go with user defined error message. Input must be numeric value. Or simple, input must be numeric. Re-execute your program. Yeah, I get a warning message. What is the warning? The variable ex2 is declared but never used. Yes, ex2 was declared by us, but we never used the ex2 anywhere. That's why we got that warning message. Okay, no issues with the warning. Warning means still your code is compiled, but there is only a warning. So don't worry about it. Run. 100. 5. No error. Result, end of the program. 100. Error. What error? Divide by 0. Exception is caught. Printing you error message. End of the program. 100. Why? Now also exception is occurred. What exception? Format exception. Now also it is caught. And displaying you input must be numeric. End of the program. Like this, it is just trying to give you or trying to handle whatever exceptions that are going to be occurring for you in the program. So what is your responsibility is identify what exceptions will occur in the code and try to handle each and every exception with a individual catch block like this. Okay, but even though we put all these catch blocks, still there is a chance of missing something. What's it? We identified 10, we caught all the 10. But there is a chance of getting 11th exception again in the tomorrow in the real-time environment. So how can I control that? If that is the case, in the last you can add catch exception. What is this? This catch block, what we have used in the last will catch all the exceptions that are left by these catch blocks. See, this catch block can catch divide by 0 only. This catch block can catch format only. Apart from these two, if you get anything else, this catch block can catch. So the specialty of the catch block is it can catch any exception that is left by the upper catch blocks. Means simply speaking, it works like an else block in a if condition or a default block in a switch case. You cannot escape from else. You cannot escape from default. Exactly. You cannot escape from this catch block also. Okay. So what to do? Console.writeLine ex.message. Whatever exceptions are not caught by the two catch blocks, this catch block will catch now. Recompiling the code. No exception, result is printed. Exception, error message is printed, end of the program. Now format exception, second catch block is catching now. First catch block is catching, second catch block is catching. Here only I will make a mistake. Now also format exception only. Now also first catch block, second catch block only caught it. Again. Yeah, I will get an exception. What is that? Overflow exception. Why? The value is bigger than the capacity of an integer. the last catch block caught it. What is the error message? Value was either too large or too small for n into 32. This is a predefined error message associated with the overflow exception. And finally, end of the program. So if you notice it, every exception was caught in the code. Okay, and this is catching all the exceptions that are left by the first and second catch blocks. So if this can catch every exception, then what is the point of having first and second catch blocks? Is a doubt which we'll have in the mind. Okay, let me explain. See, this can catch all the exception, but never use this only without those. Why means, if I use this catch block which can catch all the exception, there is a problem. What is the problem? How to perform different type of corrective actions in a different scenario. See, when I get a divide by 0 exception, I want to perform some action. When it's a format exception, I want to perform a different action. So if I put all these things through one catch block, I cannot perform different actions here. That is not possible. So what we can do is always the same action. That is the reason why first go with individual catch blocks and then add this as a last option. This should always be a last option. This should not be present first. This should always be a last option. That's what I'm telling you. It works like a else in a if condition or default in a switch case statement. So this is the process how you are going to handle an exception in your application. Thank you for watching the video. For more videos, please subscribe to our YouTube channel, Naresh IT.